This is a line of 12 impatient drivers driving their dozen cars right towards you. You're a parking assistant whose job is to hand out number slips for the 12 parking slots. The drivers, in the order that they are coming in, go to the spot with the same number as the number on their slip. If the spot is free, then they park there. But if it's occupied, then the driver finds the next unoccupied parking spot and parks in that place. A driver keeps moving forward angrily in search of a spot and they cannot be bothered to reverse and park. If a driver reaches the end and still can't find a spot, they will just drive off. If that happens, you're going to get bad reviews and will probably be fired. As you see the drivers approach, you hurriedly print out 12 random numbers, some of which might be the same, and you hand them to the drivers one by one. Now, all you can do is cross your fingers and see the action unfold. But as you do that, all you can think is, what really is the probability that I can keep my job? If you want to give this problem a shot, here is the setup and the rules on the screen. If not the exact probability, can you find what the probability is at least as big as? Pause the video to work it out yourself. Hope you had fun with that. There are some other nice examples that you can try. If you gave everyone a different number, then all of them get a parking spot. If you gave all of them the slip numbered 1, then the first driver parks in spot 1. The second driver comes to the first spot, sees it's occupied, and then parks in the next available spot, which is the second one. And this happens for everyone in the back too, and so everybody gets to park. But on the other hand, giving half of the drivers slip numbered 1 and the rest half the slip number 10 is a recipe for disaster. Before we get to the solution, let us look at two tweaks to our setup. What if the parking lot was a circle? Then, in that case, the drivers could just drive around until they found a parking spot and park there. In this really generous world, it wouldn't matter what slips were handed out. But clearly this is not our setting. So we need to add a little something to relate it to our case. What if you got cheeky and put up a makeshift 13 spot and reprogrammed the system to print out the number 13? Then, in this case, if anyone makes it to the 13 spot, then either you handed them out a number 13 or someone was just about to drive off in a previous scenario but saw the makeshift 13 spot and parked there. If your boss gets to know about any of this, you could really get into trouble. But if we combine these ideas together, we do have a working solution. Add a 13th parking spot and then make the parking lot into a circle while retaining the numbering. The drivers can now move around and find places to park as they normally would. Once all the drivers have parked, there would be one empty spot as the number of spots is 13 while the number of drivers is 12. And if the 13th spot is filled, then we know that this corresponds to a situation where a driver would have angrily driven off. Now, what if we increase the numbers on the tickets by 1? That is, the driver who got 1 now gets a 2, the driver who got the number 4 gets a 5, and the driver who got 13 gets the number 1, like numbers on a clock. The effect of this is that all drivers move to the next immediate spot, like the rotation of a circular parking lot. Notice that the empty spot moves into the next numbered spot. If we do this ticket number increasing shenanigan 13 times, then we can make the empty spot go a full circle. On its way, out of these 13 configurations, there is exactly one in which the spot number 13 is empty. This corresponds to a straight parking lot case where all the drivers get a spot and nobody drives off. In the circular parking lot case, the first driver can get 13 different numbers, so can the second driver, and this goes on till the 12th one. The total number of ways to hand out tickets is the product of all of them, which is 13 multiplied by itself 12 times. But we saw that only 1/13th of all configurations are legitimate in the case of the straight parking lot. So we get that 13 to the power 12 divided by 13, which is 13 to the 11 configurations, are the ones which will help you save your job. So the number of configurations of the circular lot in which the 13th spot is empty is the same as the number of ways one can hand out tickets so that everyone parks in the straight parking lot. But notice that a 13th spot empty configuration can only be achieved if the slip number 13 is never handed out. So you only end up handing out the tickets numbered from 1 to 12. A nicer way to see this is to imagine all possible parking configurations in which all 13 slips are distributed. Within these configurations, there are some where only the slips numbered 1 to 12 are given out. All of the nice configurations where everybody gets to park occur within this 12 slip setup. In the straight parking lot scenario, the number of ways to hand out slips to one driver is 12. So the total number of ways is 12 raised to the 12. Not all of these configurations will result in parking for all, but exactly 13 to the 11 will do. Thus, the probability is 13 raised to the 11 over 12 to the 12, which is about 20%. Your odds of staying here aren't looking too nice. Or maybe it's for the best. One shouldn't have to deal with angry customers anyway. So there you have it, an elegant solution to a simple problem, all made possible with a nifty trick and a slight change of perspective. Thanks for watching this episode of A Page from the Book. This episode was produced at the Science Media Center at IISER Pune under the coordination of Vivek, Kannadi and Arnab Mukherjee. Sugat, Kokiloo and Yuvraj Chaudhry are our technical team, and I'm your host Aditya Khanna. See you in the next episode and subscribe to our channel to stay updated.